Hi everyone, John here. Today we've got the fun job of seeing how we can fit two Daly Smart BMSs into our 60 volt twin battery electric scooter, which features two 60 volt batteries, 20 amp hour, and at the moment they both have just standard BMSs, nothing smart, nothing very clever, but we're going to upgrade these now to take the batteries out and fit the two Daly Smart BMSs, which should be a fun little exercise. Here we have the box containing the two Daly Smart BMSs. So let's get them unpacked and we'll have a look to see how we can get these installed into our two 60 volt battery packs. Living in Thailand as I do is pretty hot. Today is about 36 degrees. Fairly high humidity, so we like to do all our work wherever possible under the cover of the outside garage. So we're in our little temporary workbench with the fan, a little bit cooler, and we're going to get to work and have a look and see what we've got inside the Daly box. So we have our two packs of sensor leads and connection cables, which we've obviously got to connect up to the individual cells within each of the battery packs, and we have the two BMSs. Now we've got two different ones to test here. We've got the Daly blue version here, which is a combined BMS and smart battery balancer, all combined in the one unit, which is really neat. So you've got BMS with active balancing, and you've got the active battery manager as well, which will monitor your batteries 24/7 and make sure everything is okay. And of course you can monitor all this via Bluetooth or Wi-Fi on the app on your phone. So that's one, and we're doing a test here to try two different BMSs. And this is the second BMS, which is the Daly Smart BMS, which does everything very in a similar way, but doesn't have the active battery manager built in. So we can try both in each of the battery packs and just see how well they work. In our CityCoco scooter, as we said before, we've got the two 60 volt 20 amp hour battery packs connected in parallel. So in fact we can take one battery pack out to start with, disconnect it using the standard supplied 3-pin plug, and this will still enable us to use the scooter on the remaining single battery whilst we're working on the battery packs. So our first job is to get the keys, unlock this battery pack, take it out from the scooter, get it on the workbench, and let's take it apart. Using the key, we've unlocked the first of our two 60 volt battery packs, so let's lift him out. And here it is, a big beast. So we'll get it on the workbench and let's start taking the case apart, have a look inside. First job is to remove the 9 screws around the perimeter of the case and expose the battery pack inside. So let's get cracking. Let's reveal what's inside. And here we have it. The interesting thing with these battery packs on the scooter is that they're actually 8 years old, and they've been performing very well and no problem at all. So it's a great opportunity now to upgrade them to the new Daly Smart BMSs. So having undone the case and removed this pack, I just need to explain as we take it out from its housing that about 4 years ago this pack with its original non-logoed BMS, the BMS actually failed, and I did actually already replace it with a standard Daly BMS, which has been working absolutely fine ever since. So this is the standard Daly 16S 60 volt BMS. It's not a smart BMS, so you can't connect it to an app on your phone and computer and monitor the status of the cells, but it should mean that this particular pack will be quite easy to convert to the new Daly Smart BMS, which we will be able to connect to the app on our phone, and in future be able to monitor everything that the cells are doing. So this particular pack should be a straight switch. So let's have a look and see if the sensor wires are exactly the same, and it looks like they are. The positives are the same, negatives the same. So it's just a straight plug and play almost, with just the power wires needing to be changed over with new terminations. So let's get to work on this one. Now I've disconnected the sensor plug. The next thing we need to do is disconnect the P- and B- wires, and then we can attach the new P and B- wires to the new active Smart BMS, and then we can cut one end off of each and join them onto the existing wires going into the battery pack. Fortunately, when I fitted this last basic Daly BMS, I actually added bullet connectors in the line here, so it's very easy to disconnect this particular old one by just pulling off the bullet connectors, and then all I need to do is to desolder these two and solder them on to the new connector leads, which will bolt on to the connection points on the new BMS. So for this particular job, we'll be using our 100-watt soldering irons. They've got plenty of heat. We've got our mini vise holding the wire, and when this is hot enough into the sec, we'll apply heat and some solder and then pull the connector off of the wire. We've tinned the tip. We'll just apply heat and solder to make sure we melt and transfer the heat properly. And we'll get the pliers and ease the connector off as the solder melts. And there we go. One connector removed easily, and then we'll reconnect this to the new wire in a minute. So we'll just repeat this for the black P- wire, remove the connector, and then we can get resoldering. Using our wire stripper, we'll just remove sufficient on the B- wire, cut the insulation, pull him off simply, and then we can tin this and be ready to fit into the connector. We'll now apply a little bit of solder flux to the bare wire, just to make sure the solder flows perfectly. Can't be a bit of flux. We'll pop the connector on to the end. It's a nice little hole in the connector where we can feed the solder in to make sure it penetrates the wire completely. And there it is. And there's our finished connector. We'll just clean that up ready for installation and get on to the next one. So here we've just repeated the process. We've removed the connector from the original BMS, and now we're just going to resolder it onto the new connector lead for the new BMS. So a similar process. I've put some flux on the wire. We'll just tin the tip of the soldering iron, which is now very hot indeed. Apply some heat. And that's the second one all done, soldered on, ready for covering with some heat shrink film before we connect it up to the BMS. We've put the heat shrink tubing over this particular one, and as this is the female, we can cover the whole of the length of the connector for insulation, and we can just shrink it in place with a little bit of heat from the body of the soldering iron. And there we have it, all shrunk, ready for connection. We'll repeat that with the other connector, but on the male part we obviously have to leave this part exposed to go into the female on the other end. We leave it like this and heat shrink into place. Insulated ready, and we'll just put some extra tape on the other end coming out of the battery pack to make sure those connectors are also insulated similarly. So here we have it, the BMS with the Wi-Fi module plugged in into the UART1 port, and the two NTC temperature sensors plugged into NTCA. There's also NTCB, so in actual fact you can run 4 temperature probes into this BMS to monitor 4 different items, but on this one we're only using just one set of 2 probes, which we'll put inside the battery pack. So that's basically now ready for installation and connection, so we'll get cracking with that. Our next job is to connect the B- terminal on the BMS to the negative, total B negative, battery negative on the battery pack. We connect those two together, and then we plug in the sensor cable and we measure a couple of voltages to check everything's correct before finally plugging the whole system in. So carefully we plug in the B- to the B-. That's connected. We leave the P- disconnected for the moment, but we now plug in the sensor wires. But of course I couldn't plug in the sensor wire plug, because in the 4 years since I had the original Daly BMS, Daly have moved to a much more secure snap-on plug, which is totally different, and so I had to remove the original one and replace it with the latest. So we're now ready to connect up and test the system. So we've got the correct sensor plug to match the BMS, the Daly Smart BMS, already wired for plugging in. We've got the main battery minus and P- leads wired up with their connectors. So the first thing we have to do is to plug in the B- into the main battery negative, and then we plug the sensor lead in, and then we check some voltages. So let's just plug in the B- to the main battery negative. That's plugged in there, and we plug in the sensor lead. Very tight plug, that's in. We did get a green flash from the light, which means everything's connected correctly. And now we get the meter and we check voltages. So what we have to do here is check voltages between the main battery positive, which I'm plugged into, and then we check on the BMS, the B- and the P- should display the same voltage. So B-, 64.4 volts, and coming out 64.4. So the voltages are exactly the same, which means everything's connected properly, and we're basically ready to complete the rest of the installation and packing this back into the battery pack. That's a relief, jolly good work. We can get this packed away and then we can test it out and see how it works. Now we have the BMS connected. The green indicator light is flashing to showing the system's working fine. Every 3 seconds I think it is for that. We've got the Wi-Fi Bluetooth transmitter receiver module plugged in. We're just going to pair that with the phone on the Daly BMS app so we can monitor what's going on with the BMS remotely, and we've got to plug in the two NTC temperature sensors. We'll just install those at either end of the battery pack, so then we can remotely monitor the temperature inside the pack as we're using it. So now we have the battery reinstalled in the scooter and everything is working fine. So the next job will be the battery in the floor, where we have to fit the other Daly BMS. So that will be our next project to follow on. And here we can see battery voltage all fine. She's a 16 cell 20 amp hour, which gives 68 volts fully charged. She's charged to about 80%. Everything's ready, and we can give it a little test ride in a moment before we work on the other battery later. Another job done, and an excellent Daly Smart BMS fitted inside one of our battery packs. Here we have the Daly Smart BMS app, and you can see now the scooter, which is named as the Zyao X12 Scooter. The 60 volt 20 amp hour battery is now connected via the app, and you can see you've got the gauge at the top showing effectively 100% state of charge. This is because I've set the capacity in the parameters at 64 volts maximum charge, because I normally only charge to 80%. So although it's actually not at 100% capacity, it's showing it here because of the way I've set the parameters. You can see below this that we've got the charge and discharge circuits are active. Remaining capacity 19.9 milliamp hours, because it thinks it's at the moment running at full charge on the 20 amp hour battery. It shows the maximum cell voltage and the minimum cell voltage, average voltage difference between the maximum and minimum voltage in the cells. And if we scroll down, you can see the number of temperatures. We've got two temperature probes in the battery pack, one reading 33, one reading 34. We've got the MOS temperature, we've got the temperature of the actual BMS unit at 37. And then you can see we've got 16 battery strings, and it gives you the individual voltage of each cell, each one of those cell groups in the battery pack. So you can see the highest and the lowest and the variance. And then it gives you a bit of information about the serial numbers, software version, etc. And that's in the status display. Now when you go to parameters settings, you can see here we're in the protection parameters, and you can set everything here to your own preferences. Single cell high voltage, single cell low voltage, some high voltage protect. I've got it set to 64 volts rather than the actual 4.2 volts a cell times 16. Low voltage protection, I've got to change that because that's a little bit high at the minute. Differential pressure, overcurrent, discharge protection, and then you can go through cell characteristics, lithium ion, battery pack capacity, reference voltage, all the information here that you can adjust and set. This one here is telling us basically I've got one temperature board with two sensors, but you don't need to change any of that. That's really set by the factory. Temperature protection, so you can check the boxes here and change the high temperature, low temperature protection, discharge, high and low temperature protections, differential temperature protection, fan on temperature, heating on temperature, and overall parameter settings. I've got the charge switch and the discharge switch is on, so it will charge and discharge through the BMS, and it will upload data as required. So you've really got fantastic control over your BMS as to what you want it to do, how you want it to operate. and as I say, you go back to the status display and you've got the overall status. Now the good thing with this is, at the moment I've got it connected via Wi-Fi. If I disconnect the Wi-Fi, it will then link via Bluetooth. So if I'm out on a ride, I can run this on the phone using the Bluetooth connection. When I'm at home or away from home and I want to monitor the battery, I can do it through my home router on Wi-Fi. So wherever I am in the world, I can monitor the state of charge, the characteristics of the battery, change any of the settings, etc, etc, and do it all remotely. So you have the two options: Bluetooth when you're working locally, riding the bike or your scooter and want to monitor on that ride, and then once you are basically home and not using the scooter for riding, then you can go on the Wi-Fi, connect it via your home router, and then wherever you are in the world you can access exactly what's happening with your battery. So it's a brilliant system.